Hello everyone, welcome to the Matway Virtual. Hope you are doing good. Today I am going to continue with chapter number 3, that is machine level representation of programs. That is how we can represent the program with the help of machine level language, that is zeros and ones. In the yesterday's class, we have covered topic number 9, that is your heterogeneous data structure and union. Today I am going to start with topic number 10, that is your pointers. So I'm starting with the review or the last concept or the yesterday's class topic, that is quick review of the yesterday's class or the revision of the yesterday's class. So now let's see what we have covered in the yesterday's class. In yesterday's class, we discussed about the arrays. What are arrays? Array is a collection of homogeneous data structure. That is, it collects a data or similar data type. Means it collects the data of similar data type. Suppose I am collecting the data of int type of 5 values. That is int A5. A is the array that contains 5 variables or 5 values of integer type. So int A5 means 5 values of integer type. A means your array name, that is int A5, and arrays always start with index 0, that is if I am storing the array values as 5, so it starts from 0 and ends with the 4, that is 0 location, 1 location, 2 location, 3 location and 4 location. So it starts from 0 and ending with the last one, that is where if there are 100 numbers, so 0 to 99, and this is known as index, number 0, number 1, number 2, number 3 and so on. And the number 0 is your first element and last element is your whatever the element, suppose 100, so 99 is your last element. So this is C programming language provides a data structure known as array which can store a fixed size sequential collection of elements of same type. Means it can store a fixed size sequential collection of elements of the same type. Same type means it either may be int, it may be double, it may be void, it may be char. That is your array. An array is used to store a collection of data, as I told you. Now, next topic is your declaring the array. How we can declare the array? This is the syntax. Type means data type, array name, array size. Suppose balance is the variable array, that is type, double, array size is 10. So this is balance is the variable array. The name of the array is balance, which is sufficient to hold up to 10 double numbers. The array size is 10 and the type is, or the data type is double. Then how we can initialize, this is the method we have studied how we can initialize the array in the C language. Then we have also discussed how we can analyze or how we can initialize the array without using any specifier. That is, this is double balance 5, that is it contains 5 numbers from 0 to 4. But here there is no number mentioned, so it contains any number. It is just big enough to hold the initialization it is created. Next is you will create exactly the same array as you did in the previous example. That is balance 4 equals to 50. This is the last element starting from 0 and ending with 4. There are total 5 elements. This is at 0 location, 1 location, 2 location, 3 location and 4th location. This is the above statement assigned element 5th in the array a value of 50. Then how we can access the array elements? This is the way how we can access the array element. Means the balance at the 9th location, that is your last record, that is your 10th record is going to or assigned to the salary variable that is of double type. This says the above statement will take 10th element from the array and assign the value to the salary variable. This is the example what we have discussed in the yesterday's class. These are the output of the example. Then we have also discussed the C array in detail. That is multidimensional array, passing arrays to function, return array from a function or pointer to an array. Then we also discussed what is pointer, some basic of pointer. But today I am going to cover the full topic, that is pointer. So pointer is a variable that can store the address of another variable. Another variable means any other variable it can store the address of another variable. Like any variable or constant, you must declare a pointer before you can use it to store any variable address. The general form is type star asterisk variable name, like this one. Int pointer IP, that is IP is a pointer variable that stores the integer value. In the same way, TP is the pointer variable that stores the double value. Next, pointer arithmetic, how we can add? We can add the values depending on the memory location, depending on the data type of the size of the data type. It is either added or decrement or divide or multiply. Means we can perform any operation or any arithmetic operation. It may be addition, it may be subtraction, it may be multiplication, it may be division. Any operation we can perform on the pointers. Then we also discussed about the 2D array. 2D array means two-dimensional array, more than one row and more than one column. Suppose I am using 2 rows and 3 columns, or 3 rows and 4 columns. So columns are starting from 0 to 1 2, means 0 to 2, because there are 3 rows, and columns are from 0 to 4, or 0 to 3, that is 4 columns. Then this says physically in one block of memory, int my matrix 2 4. 2 is your rows and 4 is your column. This is 2 4. So first of all rows and then columns. There are 8 numbers, that is 1 2 3 4, that comes in first row. This comes in second row, and the columns are 1 2 3 4. This is 1 2 3 4 5 6 7 8, row 1 and row 2. Then 2D array name and addresses. Means how we can define the 2D array name and their addresses. Next, how we can access the array element. This is the method how we can access the array elements. Then how we can declare, we have also discussed hash define rows 3, means we have predefined the rows as 3 and we have predefined the columns as 5. This is the example what we have covered. This is the outer loop, this is the inner loop. This is also an example. This is also an example what we have covered in the yesterday's class. Then we have covered how we can statically allocate array size at the time of compile time. What are the limitations of statically allocating size? Then we have also discussed how we can define the variable length array. Means how we can define the variable length array so that it can be increased or decreased as per the requirement of the user. Then at last we have discussed heterogeneous data type, that is done by using the two concepts, that is structure and union. Structure is a member variable or is a data type that is used to create predefined or user-defined data type with predefined syntaxes. It is a user-defined data type, and union is also user-defined data type. But the main difference is that structure contains or stores every number of the structure, every element of the structure in different memory. But union stores the highest number and divides that main memory or divides that huge memory, large memory into multiple chunks. That is your union. Now, structure and union. So this is your simple data type, integer, real, void, char. Then structured data type, that is your array, string. Then user-defined data type, that is your enum, structures, union. Then structured data type, it is a user-defined data type that groups logically related data items of different data types into a single unit. For example, we have discussed the structure that is employee that stores the member variable as name, employee ID, salary, address, phone number. This is the syntax for how we can define the structure. This is the keyword struct, structure name, data type, variable name, data type, variable name, and so on. And then close the curly brace or curly braces and then terminate with a semicolon. This is the example, struct employee. So struct is your keyword and employee is your structure name. Then int employee ID. Then char name 20. There are total 20 characters. Float salary, char address, int department number, int age, then curly brace close, there is a semicolon. Then we have also discussed how it is allocated or the memory is allocated in the structure. that is 8000, 8002, 8022, 24. This is the addition of 2 because int takes 2 bytes, so employee ID is of int and so it is increment of int. In the same way, cat takes 20 bytes, so it is increment of 20. Then we have discussed how we can declare the structure variable, that is using the struct keyword, then structure name, then there is a variable of the structure, that is e1. Then how we can initialize this, these are the methods what we will discuss, how we can initialize the structure member. Then how we can access, this is initialization, this is access. We can access by using the dot operator, that is e1.employee ID, e1.name, e1.salary, e1.address, e1.department number, e1.age. Then we also discuss how we can assign the structure element or how we can define the structure from one part to the another part. That is E2, E1 equals to E2, E2's values or assign the values of E2 to E1. This is the program to implement the structure. This is your structure, same structure. Then this is the program how we can implement. That is e1.employee ID, e1.name, e1.salary, e1.address, e1.age. In the same way, we can use E2, E2, E2 and access the every element of the structure. These are the multiple outputs. Then we also discuss how we can use the array in the structure. That is how we can use the multiple elements, multiple data type of similar type into the structure. That is your array of structure. This is the method how we can define the array of structure. That is struct, structure name, variable name, array value. This is the way how we can define the structure, the array structure. This is name, it contains 20 values. This is the example. Then we have also discussed what is the structure within the structure. That is how we can use the nested structure. That is how we can use structure within the structure. So it is used by defining the structure within the structure. First of all, this is your syntax: struct name, curly brace open, data type, variable name. Then again use struct name. So this is internal structure, that is structure within the structure. Then data type, variable name, structure variable, then data type, variable name. This is the method how we can define. This is the structure employee. We can define the structure date within the structure employee. So this is struct employee ID, name, salary, department number. Then we can define, or we will define, or we would define struct date, int day, month, year. Then this is the structure variable of the date type. That is structure variable DOJ, date of joining. Then close with the curly brace. Then how we can access the structure within the structure? By using the double dot operator, means using the two dot operator. That is how we can access the structure within the structure. This is the example: e1.doj, that is date of joining dot day. In the same way, e1.doj dot month. Then we also discuss how we can use the pointer within the structure. This is the syntax: struct employee pointer emp, and how we can access by using the dot operators. By using the arrow operators. This is pointer variable name, arrow structure name, employee name. Then how we will also discuss how we can pass the structure to a function. These are the multiple examples. Then we also discuss how a function returns the structure. Then next one is your next heterogeneous data structure is your union. Union is similar to the structure, but the main difference is that union allows different types of variable to share same space in the memory. So union takes the large one data type, that is for example double, and it will share the same space to the multiple variables of the union or multiple data members of the union. This says this data type allocates the space equals to space needed to hold the largest data member of the union. This is the same syntax, only the keyword is different, that is struct, union name, same, then close with the curly brace and semicolon. This is the example of union, how we can use the example or how we can discuss the example of union. This is the union employee. These are the multiple union elements or union variables. How we can allocate the memory in the same way we discussed in the structure. Now, next part is your difference between structure and union. Means what is the main difference? We have discussed the two differences. Then we have also discussed what are the applications of structure. Means how we can use the structure in which applications. It is generally used in companies for storing the databases. Then we have discussed the summary. Means what is the summary? How we can use the summary, how we can define the summary in this one. So that's all for yesterday's session. Now today I'm going to cover with next topic, that is your 10th topic. Tenth topic is putting it together. Means whatever we have discussed, putting it together using the concept of or understanding the pointers. So this topic is related to a pointer. What is pointer? How we can use it, and how we can perform the arithmetic operations on the pointers. So let's start with the pointer. Pointers are the variables. It is also a variable, but that can hold address of another variable of same data type. In variables are simple, the pointers are simple, the variable, but it can hold or it holds address of another variable. It cannot hold the value, but it holds the address of another variable of same data type. This is the mandatory condition. Pointers are one of the distinct and exciting features of the C language. It provides power and flexibility to the language. Although pointer may appear little confusing and complicated in the beginning, but trust me, it's a very powerful tool and handy to use it once it's mastered. Means first of all you think that this is very boring topic, very tough topic, but as you can do the practice of the pointer, this is very interesting and used in the C language more efficiently and effectively. Then what are the benefits of using pointers? Pointers are more efficient in handling arrays and structure. As we have discussed right now, structure. So pointers are used as a structure. Pointers are more efficient to use in the arrays whenever there are more than one element, and the structure whenever there is a user-defined data type. Then second point says pointer allows references to function and thereby helps in passing of function as argument to other functions. It also allows references to function. Means we can pass the function from one part to the another with the help of the pointer. We can pass the address of one address to the another part with the help of the pointers. Then next point says it reduces length and the program execution time. Length means it reduces the size of the code and the program execution time, that is your running time of the program. Then next point is it allows C to support dynamic memory management. So it allows the C language to support dynamic memory, means we can allocate the memory at the time of runtime, at the time of execution time, that is dynamic memory management. These are the multiple benefits, advantages of using pointers. Then concept of pointer. Whenever a variable is declared, system will allocate a location to that variable in the memory to hold the value. The location will have its own address number. As you know, every variable stored in the memory must have a unique number, must have an address number. That address number will define or will give by the pointer. So pointer stores the address of another variable of similar data type. Let us assume the system has allocated memory location 80F for the variable A. This takes example, that is the memory location or the memory address is 80F for the variable A. Now declare int a equals to 10. That is, a is of int type that holds the value, that stores the value as 10. This is how we can discuss and how the computer stores in the memory. The value is 10, the name of the location. Value is 10, the name of the location is A, this is the address ATF, and this is the location. This is the location container. This is 10 AATF. This is, we can access the value 10 by either using the variable name A or the address ATF. So we can access the 10 value either using the name location. Name location means 8, or either using the address, that is your ATF. Since the memory addresses are simply numbers, they are assigned to other variables. So these addresses can assign to other variables as these are the addresses. The variable that holds memory address are known as pointer variable. So the another variable, for example B, that stores the address of A, that is ATF, that is known as pointer variable. So A is simply a variable. Now if I am storing the address of A to the B, then B is a pointer variable. This is, a pointer variable is therefore nothing but a variable that contains an address which is the location of another variable. Which is the location means address of another variable. The value of pointer variable will be stored in another memory location. It is not stored in this location only, but the pointer variable address or the value of pointer variable is stored in another address for another memory location. This is the address of A, ATF, stored in the pointer PTR and is stored in the another location. This is ATF that have a address and that contains 10A. This is ATF, this is the address of pointer. So this is the address of variable A, this is the address of pointer variable PTR. Now see the difference. This is only a value, this is address, this is the address of the pointer, this is the address of the value A. Now next part is how we can declare a pointer variable. Means how we can discuss or how we can declare a pointer variable in C language. The general syntax for declaring the pointer is data type pointer pointer name. So we can use or we can access the pointer, declare the pointer by defining the data type like int, float, double, char. Then there is a asterisk sign, then there is a pointer name. Asterisk means this is star sign, there is a pointer name. Then next says data type of the pointer must be same as the variable. So as I told you, it is of similar data type. So this says data type of pointer must be same as the variable which the pointer is pointing. Void type pointer works with all the data types. So this is the void type pointer that works with all the data types but is not used oftenly. There is a void pointer that is used with all the data types but not used very often or but not used very oftenly. Then how we can initialize the pointer variable? This is how we can declare. Now how we can initialize the pointer variable? This is pointer initialization is the process of assigning address of a variable to pointer variable. As I told you, we can assign the address to the another pointer variable. So pointer initialization is the process of assigning address of a variable to a pointer variable. Pointer variable contains address of variable of similar data type. In C language, this is the most important line. Address operator, that is when ampersand is used to determine the address of a variable. When we are using the simple number or the digit, that there is no operator used, but in C language, address operator is used to determine the address of a variable. Then the address operator, this is immediately preceding by a variable name, returns the address of the variable associated with it. So whenever we use ampersand with any operator, that returns the address of the variable that is attached to the ampersand. That is your ampersand that is address operator. This is int a equals to 0, int pointer ptr. Int a equals to 0 means we are declaring a value variable a and it contains the value 10. Then int pointer ptr, this is your pointer declaration. Then using the ptr, this is the pointer. Now storing the value, we can store the value of a to the ptr. We can store the address of the a to the ptr, not the value but the address. This is pointer declaration. First of all, pointer will be declared, then we can store, or we store the value, we can store the address of the a to the ptr. Or int pointer ptr equals to ampersand a, means these two lines are combined into one part. Use for int pointer ptr equals to percentage a, or first of all define and then using with the another one, that is your ptr equals to percentage a. So we can access any method, either use two lines, either use only one line. So this is your pointer declaration, this is your pointer initialization. This is initialization and declaration together. So you can use any way. But if we are using different data types, then it is not possible to cover, it is not possible for the pointers to store the address variable. For example, we are taking there int, here also it is int, means both are of same type, same data type, but in this example this is float and this is int. So it is not cop up, or it is not used efficiently, as this is float and this is int. So it is not cop up, float a, int pointer ptr. So a has a value, or a has a data type float, it contains decimal number also, but pointer variable is of int type, and we can store, or we want to store the address of a to the ptr, but ptr is of int type and this is of float type, so there is a mismatch of the data type. So this is the error, type mismatch. So the main condition is that the similar data type is used for declaring the value, or for variable and for the pointer variable. This is dereferencing of pointers. Means how we can dereference the pointer? By using the star operator or asterisk operator. This says once the pointer has been assigned the address of variable to access the value. Now it is the time to access the value. Till now we have discussed how we can define the, or how we can store the address. But if I want the value for that address in the pointer, that is known as, or that is done by the indirection operator, and that concept is known as dereferencing of the pointer. This says to access the value of variable, pointer is dereferenced using the indirection operator. Now let's see the example. First of all, defining the two variables. One is a, simple a, another one is pointer variable, that is pointer or asterisk p. Then defining the value to the a, that is 10, storing the address of a to the p. P is a pointer variable, storing the address of a to the p. Now use multiple printf. First of all, printf %d, comma, pointer p. Pointer p means using the values of the p. Now let's see how it is stored, or how it is used. This is one example, this is one example. And it's not working over here, so let's start with. So this is the concept, this is printf %d, right? This is printf %d pointer p. This is This is pointer P, right? But P has already stores ampersand A. So this is pointer, that is dereference ampersand A, right? So that gives the value because these are crossing each other. As in math we have studied, two numbers are cross each other. In the same way, in pointer, this is ampersand operator and the star operator is connecting or cancelling with each other. I'm repeating again, this is pointer P and P contains, or the P has a value of ampersand A. So this is the formula in pointers, that star and the difference operator and the star and the address operator are cancelling with each other and gives only the A value. So this is pointer P, so this gives the value of A because the ampersand and the pointers are cancelled. Now this will also print because these are cancelled with each other. This is only we have given pointer and the address operator in the same line, in the same point, at the same point. Then this will show the or print the address of A. And this is ampersand operator and ampersand is known as address operator. So this will show the address of the A, that is where the address or where the value of A will be stored. Then next one is your printf percentage %u. As you see, whenever we want to print the value, we are using percentage %d. But whenever we want to print the address, that is done by the percentage %u. This is percentage %u P. So this says this will also print the address of A. This is P because P contains address of A. So simply prints P. This is also print the address of A. So this shows multiple ways how we can print the value of A and how we can print the address of A and P. These are the two methods how we can print. Either use star P, either use star ampersand A, address simple ampersand A, and ampersand A is address stored also in P. So using either P or ampersand A. Then this will print the address of P. This is ampersand P. P contains address of A. So this stores the address of P, means the address of pointer where the address of A will be or A will store. So this is the multiple ways how we can use the pointers. Next is your pointers and arrays, means how we can use the arrays with the or how we can use the array in the pointers. This says when a pointer is declared or when an array is declared, compiler allocates sufficient amount of memory to contain all the elements of the array. Suppose I am declaring the array as array 5. So it will give the memory or it will allocate the memory to the different 5 elements that start from 0 to 4. This says whenever we allocate or whenever we declare the array, so the computer gives the sufficient amount of memory to contain all the elements of the array. So this is how we can declare the array. Suppose int arr 5 equals to 1, 2, 3, 4, 5. This is assuming that the base address of array is 1000 and each integer requires 2 bytes. The 5 element will be stored as follows. This is the way how elements are stored. This is ARR0, that is your first location. This is your 1000, then 1002 because it is of int type and int takes 2 bytes. So this will be incremented by 2 numbers, that is 1000, 1002, 4, 6, 8. This starts from 0 and ends with 4. This is here variable ARR will give the base address, which is the constant pointer address pointing to the element ARR0. Then therefore ARR is containing the address of ARR0, that is 1000. So this is the variable how we can give the base address and how we can use the pointer variable. This is the address 1000 and this is the element ARR0 and this is the number which is stored in this. This says ARR equals to ampersand ARR0 and this is the address. So this is denoted by ampersand address operator that is ARR0, that is array 0. Next is we can declare the pointer of type int or pointer type int to the point of array, that is arr, that is array. So this is how we can declare the pointers and array. Then we have also this is another concept, that is pointer to the structure, means how we can use the pointer within the structure. We have also discussed in the last class how we can use the pointer within the structure. Now this is coming along with the pointer also. This says like we have array of integers, array of pointers is also possible. Array of pointers etc. We can also have an array of structure variable, means we can define the multiple structure variable, or we can define the multiple variable structure in the structure element. And to make the use of array of structure variable efficient, we use pointers of structure type. As I told you in the yesterday's class, whenever we use pointers in the structure, so for accessing the values, we use the arrow operator for accessing the values. So this says we use pointers of structure type. We can also have pointer to a single structure variable, but it is mostly used with array of structure variables. So this says we can define the pointer with single variable also, but it is mostly or often used with the array of structure. Means there is an array also, there is a pointer also, there is a structure also in the structure element. Then next, this is your example, struct book. So book is your structure and struct is your keyword, curly brace open, char name 10. So name is the array variable that stores 10 characters, that is from 0 to 9, and char is your data type. Then int price. So price is a variable name that is of int type. Curly brace close. There is a semicolon missing. This is the error. This here semicolon must come. Then int main means starting with the main function. Now declaring the single structure variable. This is struct book 1. This is the structure name. So this is using struct keyword book, structure name A. A is your variable. Then using the pointer of structure type, that is struct book pointer, that is asterisk ptr. So this is of ptr is the pointer that is of structure type. Then storing the value of address of A to the ptr. So this is storing the address of A to the ptr, that is ptr equals to ampersand A. Ampersand A means address of the A, and that address will be stored to the ptr. Ptr is the pointer variable. So ptr pointer variable stores the address of A. Then next is struct B book B10. This is how we can declare the array of structure variable. This is your single structure. This is array of structure. Simply using struct keyword, book is your structure name A. This is your B10. So this is your array elements that have 10 values, that is from 0 to 9. So this is a 10, that is from 0 to 9. Then struct book pointer P. So P is also a pointer variable of the struct type. This is the pointer, that is P equals to ampersand B. So B address of B will be stored to the P variable, that is stored in the P. So these are the two examples. One is your single structure variable, another one is your array structure variable, and we are also using, or we are using both in both the concept pointer. Means pointer are used for storing the address in the single structure as well as in array of structures. Then this is how we can access the structure elements or structure members within the or with the help of pointers. As I told you in the yesterday's class, how we can access by using the arrow operators. Now this says to access the member of structure with structure variable, we use the dot operator. Means to access the array elements or using or structure variable, simple structure variable, we use the dot operator. But when we have a pointer of structure type, means when we have declared the pointer of structure type, then we use arrow operator to access the structure member. This is the example. Struct book. Book is your structure name and struct is your keyword. Char name 10. That is name is a variable, array variable that contains 10 values, and there is a price that is of int type. Curly brace close. Int main struct book B. So B is your structure member variable that is of type book. So this is struct book B. So B is your structure member variable that is B. Then struct book pointer PTR. Then using the pointer PTR that stores the address of B in the PTR. Then how we can access the structure member? Using the arrow operator. Suppose I want to fetch the structure member that is name, then using the pointer variable or using the pointer variable that is PTR, then use the arrow operator. Use the arrow operator and then name that is your Dan Brown. So this is how we can access, that is name is your Dan Brown. Then PTR price equals to 500. Means how we can access the price? It is of int type, but it is also a pointer. So how we can access with the help of pointer? That is PTR arrow price equals to 500. This is the way how we can access the structure member within the pointer, or how we can access the pointer structure member with the help of the pointers. Next topic is your pointer arithmetic. This is also discussed a little bit in the last class or last to last class, how we can perform the operations on the pointer arithmetic. So pointer arithmetic is very important to understand if you want to have complex knowledge of pointers. In this topic, which program, last program, this one, the output is Dan Brown and the 500, because these are giving the values. Yeah, these are giving the values. So output is in one line there is a Dan Brown and another line there is a 500, because we are accessing the values. But for displaying the output, we have to define printf PTR arrow name, printf PTR arrow price. All right. Is that clear? I'm repeating again. Okay, is it clear? So remember, for printing purpose, always use printf option or printf command for printing the output. Then pointer arithmetic. This is very important to understand how we can access the pointer arithmetic. This is the 16-bit machine pointer or machine example. The size of all types of pointer, be it int, float, char, double, is always 2 bytes. This says it is int pointer, float pointer, 16-bit, it is of 2 bytes. But when we perform any arithmetic function like increment, changes occur as per the size of the primitive data type. Primitive means by default data type. These are the by default data type. Int takes 2 bytes, char take 1 byte, long take 4 bytes, float takes 4 bytes, double take 8 bytes, and long double take 10 bytes. Now let's take some examples to make it clear. Suppose I am using int pointer I, then I plus plus. I is of int type and int takes 2 bytes, so this will be incremented by 1. Although the value is incremented by 1, but its address is incremented by 2 bytes. This is, in the above case, a pointer will be of 2 bytes. So when we increment it, it will increase by 2 bytes because int is of 2 bytes. In the same way, when we are using float, it is of 4 bytes, so this will be incremented by 4 bytes. So it will increment by 4 bytes because float is of 4 bytes. In the same way, double, it is incremented by 8 bytes. Although the size of pointer is still 2 bytes. Here also 2 bytes. But this will increment. Value of I is increment, so this value is incremented or the address is incremented by 8 bytes. So this is your pointer arithmetic topic. Now let's see in your book what we have covered with the help of book. This is your pointer. Understanding the pointers. Every pointer has a value. Pointers are created with the ampersand operator. We have discussed. Pointers are dereferenced with the asterisk operator. Arrays and pointers are closely related. We have discussed. Casting from one type of pointer to another type is changed but not its value. As I told you, it must be of similar data type. So this is the next point. So these are the points we have discussed with the help of PPTs. Then pointer can also point to the functions. As I told you in the last class, we can also use the pointers in the functions. These are the multiple examples. Fun is the function that contains the pointer variable. This is pointer variable in pointer p. So next topic is your GDB Debugger. So till now we have covered arrays, structure, union, pointer. Now it's a time to find out the error with the help of GDB Debugger. So this is a tool that is used to find the errors. This I will discuss, but before this let's take 5 to 10 minutes break, then come back, then discuss with the GDB Debugger. So let's take 5 to 10 minutes break. Now let's start with next topic, that is your GDB Debugger. So let's continue with our session. The GDB Debugger provides a number of useful features. So it provides a number of useful facilities to support the runtime evaluation and analysis of machine level program. So this provides a number of useful features or the facility to provide or to support the runtime evaluation. Runtime evaluation means at the time of executing, it will analyze or it will give the output and debug the programs and analysis of machine level programs. With the example and exercises in this book, we attempt to interpret the behavior of a program by just looking at the code. So this is using GDB Debugger. It is possible to study the behavior by watching the program in action while having considerable control over its execution. So this is the syntax, or this is the example how we can give the or how we can use the GDB Debugger, that is using Unix. This is the operating system. This is the command GDB program. This is the program name. Now let's see with the help of slides what is GDB. GDB, the GNU Project Debugger. The full form is GNU Project Debugger. This is GDB, the full form is this one, allows you to see what is going on inside another program. Means you have to check the program or you have to see what is going on inside the program while it executes. As I told you, it will execute, but it will run on the basis of runtime or runtime basis. So it will give or see what is going on inside the another program while it executes, or what another program was doing at the moment it crashed. Means what is wrong inside the program or what is going on inside the another program, so that what was the problem with the program or what is going on in the program at the moment it crashed. Next is the problem or program being debugged can be either written in. The program which we are debugging can be either written in ADA, that is Advanced Digital Algorithm, C language, C++, or any programming languages. This is many other programming languages. These programs might be executing on the same machine as GDB or on another machine remote. Means we can use or we are using either remote machine or either client machine for using the GDB Debugger. GDB can run on most popular Unix and most Microsoft Windows variants. GDB provides main kinds of things or support 3 or 4 types of main things to catch the bugs or to find the errors. Bug means errors. First of all, it starts your program specifying anything that might affect its behavior. So it starts your program by specifying anything that might affect your or its behavior, that affects the behavior of the program. Then make your program stop on the specified condition. So this debugger stops the program on the condition that is given in the program. So it stops on the specified condition that makes the program easy to understand. Then third point says examine what has happened when your program has stopped. So this will give the error or the explanation of the error, that is what is going wrong in the program, or examine what is going wrong in the program when the program has stopped working. Then fourth point that GDB supports is that change the things in your program so that you can experiment with correcting the effects of one bug and go on to learn about another. So change the things in the program is also done by the GDB debugger. Now, how GDB debugs, how GDB works. This allows you to do things like run the program up to a certain point, means running the program up to a certain point and then stop and print out the values of certain variables at that point. So this will give the breakpoint to in the program at various locations. So how GDB works? It will give, or it will execute, or it will put different breakpoints in the program, so that at that breakpoint the program will stop and execute or check the errors, and if there is any error, so it will stop the error or it will remove the error and then again debug the program, again go to the next breakpoint, then debug the program, find the error, remove the error, then go to the next breakpoint, debug the program, find the error and then remove the error. In the same way, in the whole program, GDB puts as many as breakpoints and removes the error at the breakpoints. This is says at certain variable at that point or step through the program one line at a time and print out the values of each variable after executing each line. GDB uses a simple command line interface. So GDB uses a command line interface that is not user defined, but this is a command line interface that uses command line interface that is uses Unix, DOS that is disk operating system, Unix is also a operating system. This is GDB debugging symbols. There are multiple symbols that are used in debugging or GDB debugger. First says a debugging symbol table maps instruction, means it maps or matches the instructions in the compiled binary program to their corresponding variable, function or line in the source code. This mapping could be something like, means the mapping table or the symbol table that does the mappings looks like something. Program instruction, that is your item name, item type, original file, line number defined. So these are the multiple program instructions which the GDB symbol will allocate. Then next is your symbol tables may be embedded into the program or stored as a separate file. So if you plan to debug your program, then it is required to create symbol table which will have required information to debug the program. We can infer a few facts. About the symbol table, that is what are the steps or what are the facts or what are the requirements that we are using while using the symbol table. First one is that a symbol table works for a particular version. That is the table that is used for comparison works for only a particular version of the program. If the program changes, a new table must be made. So this will not update it automatically, but whenever a program changes, a new table must be created or must be made to map the instructions. Then second point says debug builds are often larger and slower than retail, that is non-debug builds. Debug builds contains the symbol table and the other ancillary information. Then third point says if you wish to debug a binary program, that is if you wish to debug a binary program that is in zeros and ones, you did not compile yourself, but you can get the symbol table from the author. Means you are using the predefined symbols, you are using the predefined method for the mapping purpose or for mapping the instruction from one part to the another part. This is how we can define To let the GDB be able to read the relevant information line by line from the symbol table, we need to compile it as a bit differently. Normally, we compile the things as gcc hello.cc o hello. This is gcc hello.cc is your file, that is o hello. Instead of doing this, we need to compile with the G flag. This is a GDB debugger, so the G flag is used for GDB debugger. So this is gcc -g hello.cc -o hello. This is the program with error for the debugging purpose. This is a sample program. This contains maximum error that GDB debugger removes. So GDB debugger is used for removing the errors in the program. This is a sample program that contains the error. This says to learn C program debugging, let us create the following C program that calculates the print the factorial. As I told you, what is the factorial? Suppose there is a 5 factorial, so this is 5 into 4 into 3 into 2 into 1. So that is your 5 factorial. However, this C program contains some error in it for a debugging purpose. So this is not your perfect program. This is your errorless program because I want to use or I want to see the GDB debugger function. So this is $vim factorial.c. This is your file name. Hash include stdio.h. Int main. Either you use void main or either you use int main. There are 3 variables defined: int I, that is of int type, num j, then enter the number. Means you are entering the number, or you will ask for the user that please enter the number for which you want to find the factorial. Then store the value by using the scanf variable, by using the address of operator, that is scanf %d %num. Then using the for loop, or uses the for loop. For I equals to 1, I is less than num, I plus plus. That same uses j equals to j into 1. Here the concept is different. I am using I and I am using j. This is your num. So this is your error. Num is different, the syntax is different, this variable is different, and this variable is different. These are the multiple errors which the GDB debugger do by initializing or by inserting the breakpoints at various levels. First of all, it inserted the declaration, that is int I. It puts the breakpoint at this point, first line. Then it puts the breakpoint at this line, in the loop, at last, in the printf. This is a small program. But if there is a large program, it inserts the breakpoint at various locations where it finds suitable for finding the errors, and then collects the error and then removes the error. This is the example. Now, next is your GDB commands. This will I will discuss with the help of book, with your study material. So this is GDB debugger. This says figure 30 shows examples of some GDB commands that help when working with machine level IA32 program. These are the multiple commands that shows with the help of figure. This is your figure figure 30. These are the multiple commands. First one is starting and stopping. Command is quit. These commands I have to give in the Unix, that is in Unix operating system, to either quit the command or either quit the program, run the program, kill the program. This is first is your quit, that is for exiting the GDB. That is for exiting or for closing or exit from the GDB, we use the quit program. Then run program, that is your program, means execute your program. Then kill program, that is stop your program. So there are 3 commands for starting and stopping. One is quit, one is run, one is kill. Then next one is your breakpoints. How to set the breakpoint? The command is break sum. Set breakpoint to entry to function sum. This is a function name. So we are using the function name along with the break command, that is break sum. Then set the breakpoint at the address this one. So whatever the output or whatever the content written after the break, that is used for setting the breakpoints. Then delete one, so delete the breakpoint 1. Then simple delete all the breakpoints. Then there will be execution, means how we can execute the program. First one is your step I, execute only one instruction. Step I4, execute 4 instructions. These commands are used for execution. These commands are used for breakpoints. These commands are used for starting and stopping the function or starting and stopping the programs. Then examining the code, means how we can examine the code. This is DISAS, that is disassemble current function, disassemble function sum, disassemble this address, disassemble both the addresses, then print the program counter in the hexadecimal file. Then examining the data, means how we can examine the data. These are the multiple commands for examining the data that is used with print. This is print $EAX, that is print contents of EAX, that is your register in decimal format. Then print /XEAX, print contents of EAX register in hexadecimal file. Then print the content of EAX in binary format. Print the decimal representation of 0 into 100 file register. These are the multiple commands that are used for examining the data in the program. Then how to gather the useful information? What are the commands that are used for getting the useful information? First one is your info frame, that is your information about current stack frame. Then info registers, that is values of all the registers. Then help, how to get the information about the GDB. That is command. If I am typing help on the Unix, that gives the help for the GDB command, or that gives the information for the GDB commands. So these are the multiple GDB commands which are using with the when we are executing the program. So GDB Debugger is nothing but a tool that is used to debug the program by inserting the breakpoint at various points in the program, so that the program will execute or will run smoothly in a program. Next is your buffer overflow. Next topic is out of bounds memory references and buffer overflow. This is the next topic. Now let's discuss what is buffer overflow. Commands I have discussed with the book. Now what is buffer overflow? This is in computer system and programming, that is in computer parts, a buffer overflow or buffer overrun is an anomaly. Anomaly means it is an error where a program, while writing data to a buffer, overruns the buffer's boundary. Means suppose I am using array, that is A5, and I am accessing the value and I am defining the value 6, that is from 0 to 5. So one value is overflowing, one value is overrunning. So whenever an array is going beyond the beyond the boundary or beyond the data range, that is known as buffer overflow. So buffer overflow is an anomaly, is an error in a program while writing data to a buffer. Overruns the buffer boundary and overrides the adjacent memory. Means it overrides everything: boundary, memory, buffer, data. This is a special case of violation of memory safety. Means it violates the memory safety to some extent. Buffer overflow can be triggered by inputs that are designed to execute code or alter the way the program operates. So buffer overflow can be triggered by the inputs that are designed to execute the code. So these are triggered by the input that are designed to execute the code and then gives the error in the program. This may result in an erratic program behavior. So this may affect the program behavior, including memory access error. So there are many kinds of error which are resulting from the buffer overflow, access error, memory error, incorrect results, crash, breach of system security. That is either your program, either your system is suffering from virus or worm. Thus, these are the basis, or they are the basis of many software vulnerabilities, that is your errors, and can be maliciously exploited or maliciously exploited. These are the multiple errors, or these are the multiple attacks to the system that is provided by the attack, that is done by the buffer overflow. Programming languages commonly associated with buffer overflow include C and C++. So most of the programming languages that are affected by buffer overflow is C and C++, which provides no built-in protection against accessing or overwriting the data. So C and C++ does not provide any inbuilt protection feature, or it does not contain any inbuilt protection feature that overrides or that access or that controls you for the buffer overflow, and do not automatically check that data returned to an array is within the boundary of that array. Bound checking can be used or can prevent buffer overflow. So bound checking is one of the methods that is used to prevent the buffer overflow. These are the multiple examples how we can access or how we can use the buffer overflow. One is char buffer 10. So buffer is the array that contains 10 values, that is from 0 to 9, and buffer 10 equals to A, that is A is stored into the buffer, A character is stored into the buffer. This says in the above example we declare an array of size 10 bytes. Please note that this is from index 0 to 9. This contains 10 numbers, but from 0 to 9 can be used to refer these 10 bytes of buffer. But in the next line, we index 10 was used to store the value A. But this is from 0 to 9 and this is used as a 10. So this is an error, or this is a buffer overflow. This is the point where buffer overrun happens because data gets written beyond the right boundary of the buffer. That is, data is written beyond the boundary. Here boundary is from 0 to 9. It is written at the 10th location. So it is going from the or beyond the right boundary. Next is exploitation. How we can access or how we can use the exploitation in the buffer overflow. Now let's see in your book. We have seen that C does not perform any bound checking. As I told you, there is a concept known as bound checking for controlling the buffer overflow. So there is no concept in C language for bound checking for array references. The array is the main thing that does not contain the bound checking or the bound checking, and that local variables are stored on the stack along with the state information such as state register values and return addresses. A particularly common source of state corruption is known as buffer overflow. Typically, some character array is allocated on the stack to hold a string, but the size of the string exceeds the space allocated for the array. As we discussed in the example with the help of PPTs, array size is 10, that is from 0 to 9, but we are accessing or we are initializing the value or the variable or the text character A to the variable that is 10, but the array size is 10, that is from 0 to 9. So it is not possible to access the value at the 10th location because the maximum value is from 0 to 9 and the maximum value is 9. So it is not possible to cope up the or access the 10th value and store the output in the 10th value. This is the example. This is the example in assembly language. This is first of all push, then move the value, again push, then again subtract the value. This is the stack implementation for a function. Now, threatening buffer overflow attacks means what are the attacks that is covered or that is given by the buffer overflow. So whenever we use the buffer overflow or array is accessing the elements outside the buffer outside the boundary, what are the attacks that is available in the buffer overflow? This says buffer overflow attacks have become so pervasive and have caused so many problems with computer systems. So this creates a lot of problems with the computer system that modern compilers and operating systems have implemented mechanisms to make it more difficult to mount these attacks and limit the ways by which intruder means the hacker can seize control of a system via buffer overflow attack. So there are multiple attacks with the intruder or the hacker can introduce and uses the system or control the system or attack on the system by using the buffer overflow attack. One attack is your stack randomization. So one of the attack is stack randomization, that is stack based exploitation. Exploitation means attacking on the computer system. This says the techniques to exploit a buffer overflow vulnerability vary by architecture. So it depends on the architecture to the architecture of the computer, by operating system and by memory region. For example, exploitation on the heap is a memory used for dynamic liquidity in memory, differs marking for from exploitation on the core stack. So every exploitation means every attack on the computer is different from memory to the memory or from location to the location. Suppose I am using memory, so the attack is different on the memory. Suppose I am using stack queue, so the attack is different on the stack and queue and the memory. So there are multiple concepts for attacking in the memory and the stack. So first one exploitation is a stack based exploitation. Stack uses LIFO, that is last in first out. This says a technically inclined user may exploit. A technically means a good hacker or a good intruder may exploit stack-based overflow to manipulate the program to their advantage in one of the several ways. Means how they can attack by overwriting a local variable. Local variable means that is used in C language to overwrite a local variable that is near the buffer in memory. On the stack to change the behavior of the program, which may benefit the attacker. So how attacker will implement in the C language? By overwriting a local variable. Or it can override the return address, means it can give any address, any return address that returns a function. So that is your garbage value. As I told you, there is a garbage value. That is also an attacker, or that is also an error that is given by the attacker. Once the function returns, execution will resume at the return address as specified by an attacker, usually a user input field buffer. Third point is how the attacker overrides, by overwriting a function pointer. So the attacker attacks by overwriting or by override the function pointer, that is whenever you using the pointer, they override, they means the attackers override on the pointer. Then next last one is how they attack. They attack on the stack by using the parameter, by using the argument. So they attack on the argument which are supplied with the help of the parameter, with the help of the function. So these are the multiple ways how the stack based exploitation or the stack based attackers attacks on the systems. Next is your heap based, that is your memory based exploitation. A buffer overflow occurring in the heap data area is referred to as heap overflow. So that is a buffer overflow, that is attack that is done on the memory is known as heap overflow or the memory overflow, and is exploitable in a manner different from that of stack based overflow. So memory or the heap overflow is different from the stack based overflows. Memory on the heap is dynamically allocated by the application at the runtime. These are the memory that is dynamically allocate the memory at the runtime, means at the time of execution, and typically contains program data. exploitation is performed by corrupting this data in a specific ways. So there are multiple ways by which we can, or the attackers can corrupt the data, by using the pointers, by using the linked list, any type. Simply the main target is that exploit the memory, means remove the memory or the break the memory so that nothing will be stored in the memory. The canonical heap overflow techniques override dynamic memory allocation linkage such as malloc metadata and uses the resulting pointer exchange to override the program function pointers. So this is a heap-based exploitation. Now, what are the barriers to the exploitation? Manipulation of the buffer which occurs before it is read or executed may lead to a failure of the exploitation attempt. So whenever we manipulate the buffer, means manipulation of the buffer when it is read or executed. Manipulation means analyzing the buffer, means every time the programmer analyzes the program, that is known as manipulation of the buffer, which may lead to the failure, which may lead to the attacker to exploit on the or to attack on the computer. These manipulations can mitigate the threat of exploitation but may not make it impossible. Manipulations could include conversion to upper or lower case, removal of meta character. So these are the multiple methods that are used for manipulation that avoid the exploitation. Avoiding the alphanumeric strings. However, techniques exist to bypass these filters and manipulations: alphanumeric code, polymorphic code, self-modifying code, and multiple attacks. The same method can be used to avoid detection by intrusion detection system. This is one of the important systems that is used to exploit or avoid the barriers to the exploitation, or that is used by the programmer to remove the attackers in the program in the computer system. This says in some cases, including where code is converted into Unicode, that is where the code, the main program is converted into Unicode, the threat of vulnerability have been misrepresented by the disclosure. So this is what the barriers to the exploitation. Now let's see in your book. This is stack randomization. This is stack-based exploitation. These are the multiple examples I have set at the local variable. This is the stack implementation. Then stack corruption detection. These are the multiple examples that is available for stack-based exploitation. Then limiting executable code reason, that is your heap exploitation or heap-based exploitation. Now, next topic is your x86-64, but I think that's all for today's session. This topic I will discuss with you tomorrow, that is in the next class. Now let's see in the slide. This I have discussed. So thank you so much everyone. Now if you have any doubt, then please text the doubt and I will answer you. But before that, let's take a quick review of the today's class, that is today's session. In today's class, I have started with GDB, means what is GDB, how we can use the GDB, that is your GDB debugger, that is used to debug the programs, that is written in C, C++, Pascal. Then what are the main 4 things that is available or that is used to catch the bugs in the program? These are the main things what we have covered. Then we have also covered how GDB debugs, means how GDB debugs the main program or how GDB finds the error in the program. Then we also discussed some GDB debugging symbols. There are multiple symbols that is used for comparing the instructions in the GDB debugger. So these symbol table or the debugging symbol tables are used to map the instructions in the compiled binary program to their corresponding variable, function or line in the source code. These are the commands that is used for debugging the errors. This is the example which we have discussed. Now, next we have discussed some GDB commands from the book. Then we have also discussed what is buffer overflow. Whenever we are accessing the array element beyond its range, that is known as buffer overflow. Next, these buffer overflow are mostly found in the C and C++. This is the example. This is 10, that is from 0 to 9. And we are storing the value or the text or the character A to the buffer 10. That is illegal or that is not correct. So this is an error. Then what are the errors or what are the problems that buffer overflow gives or buffer overflow provides? One is your stack based exploitation. The main buffer overflow or the main attack is on stack, that is usually Next exploitation is on heap based, that is on memory, that is your heap based exploitation. Then barriers to the exploitation means what are the barriers that is available for exploitation. Next is we have also discussed what is pointers, how we can use the pointers. So pointers are the variable that stores the address of another variable or that stores the address of some other data type. We also discussed what are the benefits of using pointers, the concept of pointers by example. This is by using the example. Then we also discussed how to declare a pointer variable, means how we can declare the pointer variable. Then how we can initialize the pointer variable. How we can initialize by using the ampersand operator. Then we also discussed what is dereferencing pointer or dereferencing of a pointer. So whenever we want to access or whenever we have to access the value, then we are using the dereferencing pointer. Then we have also discussed arrays in the pointer. Arrays in the pointer means combination of the arrays and the pointers, how pointers are used with the help of the arrays. Then we also discussed pointer with the structures, means within the structure how the array or the pointers are defined. Then how we can access with the help of pointer by using the arrow operators. Then we also discussed pointer arithmetic, means how we can perform the operations on the arithmetic, how we can add, how we can divide, how we can multiply the operations on the pointers. These are the multiple examples which we have discussed. So that's all for today's session. Now, if you have any doubts, then please text the doubt and I will answer. In the tomorrow's class, I will start with the next topic, or the next topic is, I think x86-64. So I'm going to cover the next topic in the tomorrow's session, that is x86-64. So now if you have any doubt, then please text the doubts. So thank you so much.